Satellite engineering combines multiple advanced STEM fields, but our program makes this exciting field accessible through a carefully structured approach. So first of all, we apply a fundamental first learning approach. So we begin with intuitive, concept-driven explanation. So we make complex concepts accessible by using the real-world comparison. For example, we explain the satellite insulation by comparing it to how a thermos keeps the drink hot or cold. Students will also learn other core principles, including the black body radiation, by using the hand-on infrared camera. And we experimented and also we tested and we discussed the application of this infrared camera in astrophysics. So second, we also adapt this adaptive depth learning approach. So this program is intelligently scaled. All students first, they master the fundamental concept in phase 1, in modulus 1, and then the advanced theory will only be introduced when they need it for the specific design challenges in modulus 2 and 3. For example, in modulus 2, when the team working on the power system inside the satellite, they will learn or explore the photophotic physics in depth. While the other communication team, they will focus on the radio wave and the antenna. Third, we also apply this experimental learning cycle. Every theoretical concept is connected to the practical application. So every concept will start in the lecture, we give demonstration, and then students will have hands-on experience. And finally, they apply the concept in the real design. So students work with the real satellite component, including the gyroscope, the solar cell, the thermal blanket, from the first day in this course. Students, they will get immediate feedback through all the sensor data and the telemetry, make the abstract concept become concrete and clear to them. So finally, this program is guided by our expert. The professional engineer will provide the in-time learning when the student encounter any real design challenges. They also provide the multiple explanation pathways that are tailored to different learning styles. For the practical shortcut they use in the aerospace industry, so we have designed it and prepared a whole bunch of hands-on experience for our students. In the day one, they will already receive these 2 prototype satellites. This is called the CanSat. This one is called the CubeSat. So they will learn how to assemble and test these prototype satellites, which are equipped with the real sensors. So inside the satellite, they have the thermal sensors, they have the light sensors, they have the altitude sensor that is used to measure or detect the orientation of the satellite. We also encrypt, the satellite is also encrypted with the camera that can take the pictures and send the picture to our computer system. Then the student will learn how to program the onboard processor to process the sensor data and execute the command. So that's the first thing. And the second thing, we also prepared other launch experiment or launch simulation experiment by using the parasite. So students, they have to build their own parasite, and then they have to put their CanSat inside the parasite and test how to launch the satellite by doing the experiment using the parasite. So we will also use the sensor to test various physical principles. For example, inside the CanSat, there is a motion sensor. And therefore, by dropping the motion sensor inside the satellite using the parasite, we can test the physics or air resistance. This program is designed to be self-contained, meaning that no previous aerospace knowledge is expected. The only ideal but not mandatory knowledge, including some basic mathematics, including structural geometry and algebra. Some fundamental knowledge in physics is preferable, including the Newton mechanics or the energy concept. They are useful, but they're not mandatory. And besides that, if students are interested in coding in Python or Arduino, it will help them to start quickly in this course. But I think the most important thing is about the mindset. For those who are, the most important thing is that they are curious about the space. That is the most important qualification for this program. By the end of this program, we want the student to walk away with the real satellite engineering skills. So they will get the hands-on ability to design, build, and troubleshoot the satellite system. They will have the first-hand experience with aerospace-grade component and testing procedure. They will know how to test the satellite. Second, students will learn the problem-solving mindset. They will be resilient to all the mistakes they make. Eventually they will be comfortable with failure, with iteration and creative solution to any problems. The next thing is that the career, they will get more confidence. To design and build a satellite is challenging. If they can finish this task, I'm sure all the students become confident, and they are even confident to finish any project they will see in the future. And finally, we also hope our students learn the power to working as a team. So they will learn how to collaborate in a cross-disciplinary team, including the software team, the hardware team, and also the mission operation team all together. The ultimate goal is that we are not just teaching satellite. We are launching capable, confident engineers in our future. So whether students pursue space career or other STEM field, what they carry in the experience is proven. Is that if they can build a satellite, they can solve anything. This experience isn't just about building a satellite. It is a launchpad for future scientists and engineers. So here is how it can transform academic and career trajectories. So first, they will get the competitive edge for college and internship. The hand-on experience on the satellite is unique and rare for all the pre-university students. So it's making them highly attractive to top STEM program in the college. The second, the early exposure to the aerospace workflow will give them impressive to all the company and give them to find the internship easily. The second, we also illustrate their career pathway. So the student will discover which aerospace specialties excite him the most through this hand-on workshop. And the mentorship and the engineers provide the insider view of the space career beyond the astronaut, so including the robotic or the communication. Okay. The third thing is about the skill they have learned in this program, which can transfer to other tech fields. The satellite tech they learn here can apply to the robotics. They can apply to the AI, the big data science. They can also apply to other climate tech, including the remote sensing or the sensor network. And last but not least, this program can also give them an entrepreneurial mindset. They will learn how to do in a rapid prototyping, how to do a project in a budget constraint, and also the trade-off analysis. All of these skills are prepare the student for their startup or even in the R&D roles in the future.